Good morning, everyone. How are you guys doing?
Morning, doing good.
Good morning.
Very good. Well, let's see. This is my second lecture for today. Denise was in on the first one.
Yep, that was good.
Awesome. That's very good. Well, we've made it to part 4 of our mechanical ventilation lectures. So this is the week where we will go over some questions and work through them like we were taking the NBRC TMC exam. And if you have questions, we'll go over them. If there's something you want me to explain further, we can do that. So hopefully it will be nice and productive for us and help you feel a little bit more comfortable regarding the test. So do you guys have any questions at all before we start?
No.
Okay. Anyone else? Any questions?
No, I'm good.
Okay. Well, let me scroll down here to where we get to questions then. I haven't done these since the last time we did this, so it was 8 weeks ago, so I forget from time to time, so it'll be new for me too, kind of. Okay, here we go. So with these questions, I'm going to have you guys work through them. I'll help you with them, but I want you guys to go through the logics of what we're thinking of with the questions and just like you were taking the test. Okay, so you have here, it says, the following information has been obtained from a ventilator patient. Okay, as I start reading these, in my mind, I want to ask myself, is this normal? Is it abnormal? Do we have a problem or not? So peak inspiratory pressure. Is that a problem? 48 centimeters of water pressure?
Isn't it supposed to be 35?
Yes. Hi.
35?
Okay, so yeah, that is definitely high. And boy, this is going to be a problem. Let me see if I can change something here. My pen does not want to write, and this is going to be a huge problem if I can't get it to write. I had that problem with the last class too, and I'm not sure why it's doing that.
Yeah, it looked like it was picking up your eraser.
Yeah, that's exactly what it's doing, and I'm not sure why it's doing that. The eraser is not highlighted. I'm going to pen. So it works when I use my mouse. Let's see if it works. And with my pen, that's the problem. Okay.
Can you disconnect your pen and reconnect it?
Well, it's wireless. That's my problem here. And I'm not sure. Let me just push a button here because I really want this to get to the pen. It's so much easier. Oh, that's working. Okay. Let's try this. Okay, perfect. So we know that we have a problem with this 48 centimeters of water pressure, okay? And you're going to see that this isn't going to even have a bearing on what we're going to look for, but nonetheless, this is what I do with each question. Plateau pressure, is that okay, pressure-wise?
Yes. Yes.
I think that's high also.
Yes.
Okay, that's okay. Tidal volume, we don't have a height or a weight here, so we're just going to have to say that's okay. They haven't given us enough information to know if that's too much or not. Peak 4 centimeters of water pressure, is that okay?
It's between 4 to 6, yes.
Okay. So everything's good there, except we do have a high peak pressure. Okay, on the basis of these data, the patient's static, that's going to be important, static lung compliance is approximately which of the following? Okay, what is the formula for static lung compliance?
Tidal volume.
PEP minus plateau divided by tidal volume.
Okay,
Yeah.
so that would be for elastance, which is the opposite of compliance. But if you just flip those around,
Is
Plateau minus PEEP.
plateau minus peak.
well, it's when I say flip them around, meaning you need to put the tidal volume on the top.
Tidal volume divide by plateau minus peak.
Good job, Kedley. Okay, so plateau minus PEEP. So here's something that's important for you to know. They gave us peak inspiratory pressure and they gave us plateau pressure. We need to know which one we're going to use. So peak inspiratory pressure would be used if they wanted to know what the dynamic compliance. Plateau pressure is static, meaning it's not moving. Okay, so if we look at our breath, we have a breath come in and then it kind of comes down a little bit and it goes like that. This is our peak pressure, and that's while air is moving. So dynamic means while things are happening. Okay, so that's why dynamic would be peak inspiratory pressure that we would use instead of plateau because the air is moving. However, static is once the air stops moving, and that's why we would use the plateau pressure there. Okay, so tidal volume, 850, divided by plateau is 27, minus 4 equals 850 divided by 23.
34.
And I need to get my calculator out.
36.9.
Thank you. Okay, so 30. You said 36.9.
Yeah, so it'd be D37.
So, yep. D is the answer. Does anybody have a question with this?
No.
Now, is there any shortcut, like if this was on the test and you don't have time to sit there and divide, divide 23. I don't have a calculator.
Yeah, really, there's not. I mean, I could sit here and say, okay, well, 23, that's going to go into 100 a little more than 4 times. So 4 times 8 is 32, plus 2 times into 50, that would give us 36. Let's see, 32 plus 2 is 34. And I know it's going to be a little bit more than that, but really dividing it out is what you're going to need to do on this.
Okay.
Unless your brain can just, estimate it with the numbers that it has. Okay, let's go on to the next one. Okay, a patient is receiving volume-controlled ventilation. Okay, they're in volume. I know that we're talking about tidal volumes. In the assist control mode, okay, so in my mind, I'm thinking if they're overbreathing the ventilator, their breaths are looking like this. They're all big machine-driven breaths. Okay, and the IE ratio alarm is sounding. Okay, IE ratio. Now I'm thinking flows. Which control adjustment would correct this problem? And I shouldn't have written flow there because I just gave you the answer. Except you have 2 flows.
Increase.
So which would we do? Increase or decrease the flow?
If the alarm is sounding, so evidently it's going to be
Increase.
the high alarm.
So no, when you have an IE ratio alarm, it's going to be telling you that you are not giving enough time for your expiratory. So your breath's going in like that, and then you're coming down and you're not coming back down to baseline.
Okay.
So what you need to do is you need to get that breath in faster. Because if you look at this IE ratio, this is 1 to like 0.5.
Increase
So we're going to increase the flow?
flow.
We're going to increase the flow.
Okay.
Okay, so a couple things with this. With your flow, usually when you have an IE ratio problem, increasing your flow rate is going to be the answer. Okay, not always. Don't just put that down because Kevin told you you need to work through the problem. But usually it's going to be increasing the flow. So here are a couple things here. We're in volume control, so we know that with volume control, flow equals set. We have a set flow. If you're in pressure control, then the flow is variable. Okay, so the way to get this breath in faster, so here's a slow breath going in, and here's a fast breath going in. And the way that you get that in faster is by increasing the flow, because you're going to have to get to this level right here, that tidal volume, we'll call it 500 cc's, every breath, because you're in volume control. You've set a tidal volume. And you have a set flow. So the only way you can get it in faster is increase the flow rate. Now, for you guys who have been to the other lecture where I talk about test taking strategies for the TMC exam, you should have also recognized this. You have decreased the flow rate and you have increased the flow rate. During that lecture, I told you that when you have opposing answers, two answers that are the same but opposing each other, so we're talking flow rate, we're either decreasing the flow rate or increasing the flow rate, usually, not always, but usually, one of them is the correct answer. So that should have given you another tip that it's going to be one of the flow rates. Okay, how do you feel about that? Do you have any questions?
I'm good.
Okay. Mechanical ventilation can lead to which of the following complications? Okay. Increased renal output. Mechanical ventilation, will it cause you to pee more?
No.
B.
Okay. Can it cause barotrauma?
Yes.
Is it going to increase your cardiac output?
Yeah.
Did I hear somebody say it decreases?
Decrease.
Cardiac output.
Good job. It decreases, or I mean, it may not do anything to your cardiac output, but if it does, it's going to decrease your cardiac output.
Is
So that means that the answer is B. Any questions on that?
That's good.
Okay. Static compliance will decrease as a result of which of the following? So first of all, static, so we're talking about the stiffness of the lungs. And is decreasing good or bad?
at the like this? Say.
So first of all, is decreasing the compliance good or bad?
Good.
Bad.
Yeah, if your compliance decreases, then it's better.
Just the opposite. It's bad.
Is bad. I know.
Okay, so if it goes down, it's bad. Okay.
Yeah.
Let's see.
So if you decrease your compliance, think of compliance not even necessarily in numbers, but if something is compliant or not. You want something to be nice and compliant. Maybe you're a business owner and you want your employees to be compliant with what you want them to do. So compliance is a good thing. So the more compliance we have, the better. That might be a way to remember it. Okay, so It's going to get bad as a result of which of the following? Okay, bronchospasm. Does that affect our lungs as far as the compliance?
No.
No.
Airway resistant?
Okay, exactly. It changes our airway resistance, but it doesn't change the compliance of our lungs. Mucosal edema. You're getting swelling in your airways.
And also airway resistant.
Okay, airway resistance. Nice job. Atelectasis.
A
Yes.
lung.
Okay,
Yeah.
that definitely does. Some of your alveoli are collapsing.
Yeah, lung.
Okay, bronchial secretions.
Airway resistant.
Good job. Okay, so another way to look at this. So C is the answer, but look at these. All of these things, A, B, and D, as Kedley pointed out, all deal with airway resistance. They're the same kind of effect. Here, you're in A, your airways are getting smaller. They're being constricted. B, you have mucus and whatnot causing those airways to have decreased amount of air that can go through them. Bronchial secretion, same as the mucosal edema. Or sorry, I don't know if I said swelling or secretions on B, but that's just swelling. So those are all the same. Atelectasis is the only thing that's different from them. So that should, even if you didn't know what the answer was, if you knew what each of these 4 things were, you could hopefully have guessed the correct answer just by seeing which one of those is different than the other. Okay. This data has been collected from a patient whose ventilator was in the assist control mode. Okay, so I'm talking breaths like that, all of them machine-driven breaths. Tidal volume 800. We don't know if that's good or bad, so we're going to have to assume that it's good because we don't have a weight or a height on this patient. Respiratory rate 15 breaths per minute. That's in our normal range. Well, depends what we're setting up there. So we'll put a question mark here, okay? FiO2 45%. That's all right. pH 7.50. That good or bad?
It's a little on the alkalotic side.
Okay. So I'm going to say alkalotic. CO2. That in normal range or outside?
Yeah, it's alkalotic.
Alkalotic.
Okay. So that's I'm just going to say alkalotic, so it causes alkalosis. PaO2, good or bad?
No more.
That's normal.
Okay, so we'll just call that good. To increase this patient's CO2 to 40 millimeters, the ventilator rate should be adjusted to what? Oh my goodness. Okay, this one is a multi-step problem.
12.
Okay.
12 times
So,
30 divided by
anybody want to tell me where to start on this?
1 minute. I have a way of doing it.
Well, if you're, oh, never mind.
Weight. I usually do weight. The weight that it is now 15 times the PCO2 divided by 40. I don't know.
Okay, you're right on you're on target with this, Kedley. So there's an equation here that says PCO2, and I'm just going to put a C there for current, times minute ventilation current, and you guys need to memorize this equation, equals PCO2 desired times minute ventilation desired. Okay.
Your pen is not very dark. Not real thick. I can't. It's hard to see.
Let's see if I can do anything to change that. Huh. And I don't see a way that I can change the thickness of it. Are you able to read it, or is it?
Just need to write darker, maybe heavier.
Okay, I'll try doing that and see if it makes a difference. I'm not sure if it will or not.
Okay.
Okay, so what of these do we need to know? We want to find out their CO2, right? Or we want to change their CO2 to 40?
Right, so you have to get your minute ventilation, which is
Good.
going to be your tidal volume, your respiratory rate times your tidal volume.
Okay, excellent. Okay, so what we want to end up with is finding out, first of all, what this desired minute ventilation is. Okay, minute ventilation desired equals PCO2 current times minute ventilation current divided by PCO2 desired. Okay. What is our current minute ventilation?
It's 15. 800.
12,000?
Okay, equals respiratory rate 15 times. Now remember, your tidal volume is supposed to be in liters, so it's going to be times 0.8.
0.8, that's right.
Okay,
Yeah.
so let's see what we have here. $15 times 0.8 equals 12.
Okay.
So now I'm going to come down to this equation here, and I'm going to just keep working my way down. So minute ventilation desired equals, okay, CO2 current is 30. That's given to us. Times minute ventilation current, which is 12. Divided by CO2 desired. Well, we want it to be 40, right?
Right, so you're going to take your 30 times your 12, which is 360, divide that by your 40, and you're going to have 9.
10.
Excellent.
The answer is 8.
Okay, so we're going to say that equals
That's not one of the choices.
9.
8.
Okay, so now let's see. To increase this patient's CO2 to 40, the ventilator rate. So we're going to adjust the rate. So that means we're going to keep the tidal volume the same. So again, minute ventilation equals respiratory rate times tidal volume. And we're going to adjust the rate. So respiratory rate equals minute ventilation divided by tidal volume. Respiratory rate equals 9 divided by 0.8. Let's see, divided by 0.8 equals
11.25.
11.25. And we come up here, the closest one is B. This one is definitely much harder than what we've seen so far on these questions. Did you guys understand how we went through this? Is there anything that you want to ask me about this?
So now why didn't you just use your 9? I mean, why didn't you use your 9 and round up to 10? Why did you have to go back? Because it's I don't understand the minute ventilation, the second half, the bottom half of that.
This part down.
Yeah.
Here.
Why didn't you? Yes.
Okay.
Why didn't it stop right there at 30 times 12 divided by 40?
Let's see, 30 times 12 divided by. Okay, so that gives us our desired minute ventilation. When we put everything in and we want the CO2 to be 40, that gives us the minute ventilation that we need to have to bring our CO2 up to 40. However, minute ventilation is a factor of respiratory rate times tidal volume. and I don't know what respiratory rate I need to adjust this to get that minute ventilation.
Okay, so you plug in that 9 as your respiratory rate.
No, I put that in as my minute ventilation. So this 9 right here
Uh-huh.
is plugging in to this minute ventilation. That's our desired minute ventilation. That's what we need. And then I just manipulated this equation. So I'm saying I want to find out what this is. So I'm going to keep minute ventilation on one side of the equation. I'm going to divide, let me come over here. So let's see, minute ventilation equals respiratory rate times tidal volume. So with algebra, we know that we can do whatever we want to this equation as long as we do the same thing to both sides. So if I divide both sides by tidal volume, what happens is this tidal volume and that tidal volume cross each other out. So minute ventilation divided by tidal volume equals respiratory rate.
Okay, so you got your new minute ventilation, which was 9.
Correct.
And you divided that by the 800.
Yes, which was given to us up at the top.
Right.
And so, and the reason why I did that is because the question wants to find out what we have to adjust the rate to. Now, if it had said, what do you want to change the tidal volume to, then we would solve for tidal volume.
Okay, but if you take that 9 divided it by 800. Okay, all right, I got you. All right, I'm with you now.
Are you sure?
Uh-huh. Mm-hmm.
Okay. Anyone else have questions on this? Okay. We'll go to the next one. The following data have been collected from a patient receiving volume-controlled ventilation in assist control. Okay, so already we know they're volume-controlled and they're in assist control. So we're setting a tidal volume, and their breathing is going to be like that. Okay, tidal volume, 700 cc's. Okay, we're going to assume that that's okay. Respiratory rate, 10. That okay?
Yeah.
Yes.
Okay. How about FiO2 of 50%?
Yeah.
Yes.
Okay. PEEP of 5?
Yes.
Yes.
pH 7.44?
That's
So,
no.
yeah, it's a little on the high side, but okay.
But it's still in its
But it's
normal
still
range.
in
Right?
range.
Okay. How about CO2 of 42?
Yes, no more.
Yes.
Okay. How about PO2 of 58?
We have
It's a
oxygenation.
little low.
Okay. So this is low. So we see that we have an oxygenation problem. Okay. First of all, before you go down to the rest of the test, how do we fix oxygenation?
If you up your FiO2, but if it's already high, then you're gonna
For
rate.
Then you're,
people.
otherwise you will do what?
Increase your PEEP.
Okay, that's one of the things that you can do. You're going to increase, I'm looking for a more general term.
Respiratory
Like
rate?
the respiratory rate.
That's one of the things you can do too.
Tidal volume is also.
That's one of the things you can do too.
Increase.
Let's
Like, let me see which one. Okay.
Oh, your mean airway pressure?
Yes. You guys have to know this.
We
I want
always
you
forget
to
that word.
Physically insert this in your minds right now and never let it go. Mean airway pressure. Okay, so we'll probably find that we're going to increase the PEEP, but that's not the only thing we can do. Okay, you can do any of these things to increase oxygenation. So don't just get stuck on one thing. You know, increasing PEEP is a great way to do it. That's one of the best ways, but it's not the only way.
Okay, mean airway pressure.
Okay,
Thank you.
you bet. So now let's find where we were. Okay, so mean airway pressure. Those are the two ways that we are going to oxygenate better. Okay. Based on this information, the respiratory therapist should recommend which of the following ventilator changes. Okay. Increase FiO2 to 70%. Should we
No.
do that?
No.
No, that's over your 60. You'll cause shunting.
Good. Okay, so we're going to say no because we have a VQ mismatch.
Right.
Okay. Increase tidal volume to 800 cc's.
You don't want to do that because we don't know how much they weigh or how
Right.
tall they are.
Okay, exactly. We don't know if that's going to hurt the patient or help the patient. It would drop the CO2 down a little bit, but as you can see by the pH, we're already up near the top of the normal range, and that would make them more alkalotic, so that would not be a good thing to do. Okay, increase PEEP to 10. Would that help?
Yes.
That could help. Yes.
Okay, that would definitely help. Okay, initiate CPAP at 4 centimeters of water pressure and an FiO2 of 50%. So what they're saying is give them less support.
No,
That would be very detrimental. You would lose a lot of points on your TMC exam if you picked that one.
I'm going to say that's less than what they're already getting. So,
Yeah. So like if this is TMC exam, and this is just me completely pulling these out, I don't know what they would do, but I would say they would give you a -3 for that. They'd give you a +3 for that. They'd probably give you a -2 or -3 for that. And probably a -1 or 2 for that. So the answer here is we want to increase the PEEP to 10 centimeters of water pressure. Everyone okay with that?
Yes.
yes.
Okay. All right. A patient being mechanically ventilated in the assist control mode. Okay, assist control. Every single breath is machine driven, even if the patient's triggering it. And a rate of 12 breaths per minute is triggering the, okay. So being mechanically ventilated in the assist control mode, they are set at a rate of 12 breaths per minute, but the patient's triggering the ventilator at a rate of 34. So they're over-breathing the vent. Okay. However, all the breaths look the same because remember, once they trigger it, the machine gives the entire breath. The patient is anxious and agitated and has the following ABG results. pH 7.55. How's that?
Alkalotic.
Okay, alkalotic. CO2 25. How's that?
Alkalotic.
Okay, alkalotic. PaO2 96.
Normal.
That's good. Okay. Bicarb 25.
Normal.
That's okay.
That's good. 22 to 26 is normal. Base excess
Okay.
+1. Good.
It's fine.
Okay, so what is this patient's problem?
Is alcohol
He's hyperventilating.
Okay, hyperventilating. Which of the following medications? Oh, we're not even going to have to make any changes with the vent or anything. Just medications.
I would say Versed.
Versed?
Yeah.
Good job. That's what we want to do. Because the patient, it told you up here, the patient is anxious and agitated. And what better drug than Versed to give to a patient that's anxious and agitated? So what is most likely happening is because they're anxious and agitated, they are hyperventilating. They're in a panic attack, so to speak.
Right.
Okay. Versed will calm them down, where these others will not. Okay. So back on this, I mean, albuterol, you know what that does. That opens up the airways. So if it mentioned that they were in bronchoconstriction or whatnot, well then that could be the drug of choice in that situation. Nipride, that reduces blood pressure, so
pressure.
that's not going to have an effect on their agitation and whatnot. Theophylline, that's like a sister of caffeine. It's one of the methylxanthine classification of drugs. So if anything, that'll make them probably more anxious. Okay, a 5'7", 65-kilogram female. All right. So first of all, if we're going to talk about tidal volumes, we need to keep this in mind because this is going to be a tidal volume that we can calculate. Okay, that patient arrives in the ED. They're intubated and being manually ventilated with 100% oxygen. Okay, so bag and mask. Paramedic state, she was discovered unconscious at home. Okay, that's might be information that we need. With an empty pill bottle. Oh, what are we thinking now?
Overdose.
Overdose. Good. Okay, the respiratory therapist should select which of the following ventilator settings to best ventilate this patient. Oh, fantastic. Let's just look at the things that we should do. Okay. Who has their pursing book with them?
Oh, I can get it real quick.
6 to 10.
I'm not even sure what page it's on, but it's right around page 126, give or take a couple pages or so. Bottom left-hand side of the left-hand page. You're going to see some values, but we'll talk about them right now. Okay, so first of all, let's look at the tidal volume.
65 times 6.
Okay, 65 kilograms times, what's our normal tidal volume? What should we be setting this patient up on?
6 to 10.
Okay, let's do 6 to 8. So Kelly, that's something that they have decreased now.
They
So
just-
after the book was published, they've decreased it. It's now 6 to 8.
Okay.
Okay, cc's per kilogram. So 65 times 6.
Oh, I did.
Okay, so
390.
396 cc's, so let's call that 400. And 65 times 8, let's see, sorry, 65 times 8,
15.
520. So 400 cc's to 520 cc's is what we want. Let's see. And this is, this is based on the old one though. So Kedley, and I can already see where we're rough here. Okay, if you're in your TMC exam, this is what you want to calculate right here. Okay. But since this question was written before they went down to 8, we're going to have to go up to 10. So that would give us a range of 400 to 650.
Professor Kevin, the new book I bought for 27, they put it back to 10, 6 to 10.
Okay, which is that Persing or is that
That's Lindsey Jones.
Lindsey Jones? Okay, everything that I have is 6 to 8, so you're going to have to use your judgment on that, but I would highly go with 6 to 8.
6 to 8, I listen to you.
Okay,
Okay.
so but right now we're using this one, 400 to 650, because that is what it was when this book was published. Okay, so that's tidal volume. What's our respiratory rate supposed to be?
Between 10 to 20,
Like 10 to 20 or 10 to,
something like between
12 to 20.
no, I know.
What's your book say, Kedley?
that I did. 10 to 20.
Does it say 10 to 20?
Yes.
Okay, so we're getting some different things here from one book to the other. What about?
How about 8 to 12?
Yes, that's what I use. Okay.
8 to 12 would be perfect for me.
But in reality, that's a hard part. This is NBRC school versus regular hospital. Because in a hospital, 10 to 20 is just fine. Okay, but we're going to do 8 to 12. FiO2, what does it tell you to do with the FiO2?
Says you're showing one
The
negative.
FiO2, you're supposed to keep it the same as they are when they come in.
Good job. FiO2 is the same. So let's look at these three parameters and see what we have. Okay, patient was on 100% oxygen. So anything that doesn't have 100% oxygen, we can get rid of. There's
It's gonna be B and
60%,
D.
there's 80%. So we just got rid of D
D and
and B right off the bat. Okay, that would be the very first thing that I would look at, because you don't have to calculate, you don't have to do anything other than compare if it's the same or not. Okay,
C2 is the tidal volume is 700.
Or,
Okay.
and two, the rate is 6, so we're
Yep.
still below normal.
so that's bad,
Range.
that's bad,
Okay.
which means that's bad.
The only answer is A.
Okay, so if we didn't know what the tidal volume was, so see, Kedley's book says different than what Persing's book says. Okay, but let's say that we didn't know what the normal tidal volume was that we should use, or the normal respiratory rate. We know it's either 8 to 12 or 10 to 20. So let's say it's 8 to 20. That gives us our biggest range. We could still knock C out because of that respiratory rate at 6 without even having to calculate anything. You can just see that that is a wrong value there.
With
And
the
so
book-
this question, you really could have looked at it and answered it in probably 15 seconds worth of time after you read the question. Sound okay?
Yes.
Yeah.
Okay.
With the books that some people are using, we really just need to go by whatever the board is.
Yeah, so what is happening is these courses, Persing, Lindsay Jones, Kettering, RT Board Review, they send people to take the TMC exam over and over and over. And what they're trying to do is memorize as much about that exam as they can. And then they come back and put that onto paper and create a book that tells you, basically teaches you what they learned from that exam. So the NBRC exam isn't going to say, we want you to do this, this, and this. Basically, your school has to teach you that, and the NBRC is going to test you on it. But part of the trick is finding out exactly what the NBRC is thinking. And so that's why they
The
send these
parameters.
people in over and over again. And you may get some parameters that are a little bit different from one book to the other. But as a whole, they're all going to be very close to each other in most aspects. And sometimes it just depends when the book was published. Because if it's published, then the NBRC makes a change. It's already going to be outdated a little bit.
Okay.
Okay?
Yes.
So, as a whole, and I'm going by Persing with this, but you should do 6 to 8 cc's per kilogram, and then unless it's ARDS, would be 4
So
cc's, like 4 to, well, 4, more on the 4 range, but you can do 4 to 6
Yeah.
cc's per kilogram. Respiratory rate 8 to 12 breaths per minute. This is for starting. FiO2 is the same. What else am I missing here? Oh, so FiO2 is the same unless it's a COPD.
And you want to do the 30 to 40% if it's COPD.
Exactly. Okay. All right. A 34-year-old patient with CHF is in the ICU receiving non-invasive positive pressure ventilation by mask. So we have a patient with congestive heart failure that's on BiPAP. or CPAP. The settings and ABG results are below. Okay, so we know that they're BiPAP because we have an inspiratory and an expiratory pressure. Okay, 14/5, that's our BiPAP. Respiratory rate is 12. pH 7.29, is that okay?
Acidotic.
Thank you. CO2 51.
Acidotic.
PaO2 63.
Both.
Oxygenation problem.
Yep, they're hypoxic. Bicarb 23.
That's fine.
Fine.
Base excess -1.
Fine.
Okay. Which is
Okay, so do we have an oxygenation problem or
Ventilation.
a ventilation problem
or
or
both.
both?
Both. I would say both.
So look at it and see. You can look at one aspect at a time.
Both, but I will go with the ventilation first.
Okay, so we have a ventilation problem. We can see that because our CO2 is high, which is causing us to be acidic. We need to blow off more CO2. And we have an oxygenation problem because our PaO2 is low.
So we have both.
Okay, let's come back here. What do we do if we have a problem with both?
We'll go for ventilation first.
Nope. Think about
Or
when I taught you the golden rules.
we do the tidal volume.
Okay, that's one of the things that we can do.
And respiratory rate.
And
Okay, tidal volume or respiratory rate. You are correct. Because that will fix both of them. Let's come back up here. Okay, golden rules. If you're going to ventilate, there are two things that you're going to do to improve your ventilation. It's going to be one of these two things. Okay, that increases your minute ventilation. Okay, but you'll notice those two same things are up here for oxygenation problems. So if you're going to have to fix both of them, oxygenation and ventilation, you need to pick one of these two that are in red because those are in both lists. Okay, now you're going to come down here and you're going to see that you have a little bit of a problem because it hasn't told you about tidal volume. How do you adjust the tidal volume?
IPAP.
Okay, expound on that, Kedley.
Increase the IPAP.
Okay. Did you say increase the I or the EPAP?
IPAP.
Okay, good job.
Sorry.
So you have IPAP and you have EPAP. Okay.
For ventilation.
Your IPAP is at 14. Your EPAP is at 5. What is your inspiratory pressure?
14 minus 5.
Okay. That means that your inspiratory pressure is equal to 9. That is the magical number that we need to increase. Okay, so if we increase the EPAP to 10, what is our inspiratory pressure going to be?
4.
Okay, inspiratory pressure equals 4. Is that a bigger or a smaller tidal volume?
Smaller.
Smaller tidal volume.
Smaller, so that's not going to do. So that will improve oxygenation because your mean airway pressure is going to go up, but it's going to really hurt your ventilation. Okay, decrease IPAP to 12. What is your inspiratory pressure?
Yeah. 2.
No,
14 minus.
no, you're decreasing the IPAP to
Or
12.
decreasing the IPAP to 12. 12 minus 4, 7.
Okay, it equals a 7.
Mm-hmm.
So 12 minus 5 is 7. Okay, so if you decrease your IPAP to 12, you're going to hurt oxygenation because you just decreased your mean airway pressure, and you're going to hurt ventilation because you just decreased your inspiratory pressure, therefore you've decreased your minute ventilation. Decrease EPAP to 3.
It will fix the ventilation.
Say that again?
It will fix the ventilation, but I don't know about the oxygenation.
Okay, it's going to hurt your oxygenation because your mean airway pressure is going to decrease. Because every time that you're not taking a breath, you're only sitting at 3 centimeters of water pressure instead of 5. So what is your inspiratory pressure on this?
13.
If we have
Oh,
14 for our inspiratory, our IPAP, and 3 for our EPAP.
13.
11. 14 minus 3 is 11. Okay, so decreasing oxygenation because our PEEP went down.
I thought you was doing D, sorry.
No, you're okay. So your PEEP went down, so your oxygenation is going to go down. You are, however, going to increase your ventilation because your inspiratory pressure is the highest that it's been out of these scenarios. And it's higher than what it was originally with that 9. Okay, and then this one, increase IPAP to 18. So if we're 18 over 5, what is our inspiratory pressure?
13.
Say that again.
18 minus 5 equals 13.
Yep, 13.
That's it.
Okay, what will that do to oxygenation?
improve.
Improve oxygen, boy,
And improve ventilation, both of them.
and improve ventilation. So the answer is D. Okay. This is the last of the questions. So the following data are collected on a 70 kilogram, 154 pound female. We already did this? No, I guess we didn't. Okay. Okay, so 70 kilogram female receiving mechanical ventilation and volume control. So we're in volume. We don't know if they're in, I was going to say we didn't know if they're in assist control or SIMV, but we can see right here. They're SIMV. That means they have machine-driven breaths and they have pressure support breaths. Here's SIMV for you. All the extra breaths are the pressure support breaths. Okay. Respiratory rate, 12 breaths per minute. That okay?
Yes.
Okay. Total rate, 24 breaths per minute.
35.
Are they? Does that mean they're riding the vent or
Yes.
overbreathing the vent?
Over breathing.
Okay. They're overbreathing the vent by 12 breaths per minute.
Right.
Tidal volume, 800.
High.
Hi.
Okay, that's high. We can already tell that because for this intent right here, we're doing 6 to 10 cc's, so 10 would be 700 for a max. FiO2, 35%. Is that okay?
Yes.
Okay. Pressure support of 7. Is that okay? I'm going to tell you now. It's okay. We don't know if it's too much or too little,
I was gonna say, yeah, we don't know what's it doing?
but it's a safe pressure.
Right.
And so far, we're okay with that. PEEP, 5 centimeters of water pressure. That's good.
Normal.
Yeah.
All right. pH, what do we have?
A little on the alkalotic side.
Alkali.
Okay, alkalotic. How about CO2?
Alkalotic.
That low CO2 is causing alkalosis.
Oxygen.
How about PO2?
Oxygenation.
Hypoxic.
Low.
That's low. So they're hypoxic. Bicarb,
Normal.
Fine.
normal. That's okay. Base excess of a -2.
Normal.
It's okay.
That's okay. Which of the following ventilator changes are appropriate at this time? Okay, so what kind of problems? Let's look at problems. So we know that we have a problem here.
Mm-hmm. And problem and oxygen.
Okay. However, let's see. We have a problem here. The CO2. Basically the patient's hyperventilating and blowing off too much CO2. Okay, so this total rate of 24 is high. And these are all problems. So we have oxygenation problems. We have ventilation problems. And we have a high tidal volume. That's what we can see so far. Okay.
So it's
Do we
either-
want to?
Oh,
Sorry,
ahead.
go ahead.
No, I was just going to repeat what you did earlier. Sorry.
Okay. So if we increase the peak to 10,
Does
that-
it,
what will that do to us?
Improve the oxygen.
That'll help your oxygen.
Okay, it'll help our oxygen. Will it do anything with our CO2?
It'll help your CO2, but it's not going to, right? Let me see.
and I wouldn't do it because the oxygen, the FiO2 is 0.35. I could still increase the FiO2.
Oh, I love this critical thinking that you guys are showing. Okay, so that's a good point.
But I think
Okay.
most importantly is the tidal volume that's too high.
Is that it?
Okay.
Narrows problem.
Phase
That
B.
would be the first thing to do before you changed anything.
So that is definitely a concern, and that's high up on my mind with concerns. And that's excellent critical thinking skills. But let's go through each of these and see what will happen with each of these changes. And see if that's what your answer ends up being. So with this first one, we're going to improve our oxygenation. We're just going to be flat with our ventilation. It really will help our ventilation a little bit because you are increasing surface area, but its purpose is not to increase ventilation. It just has a little bit of effect on it. So I'm going to say it has no effect since that's not one of the things that you do to improve ventilation. And then I'm just going to say it doesn't do anything for our tidal volume, so that's not going to help us. Okay, decrease the tidal volume to 700. So I believe that was Connie, right, that mentioned
Yeah.
the
Yeah,
concern?
that was it.
Okay, and it is an absolute legitimate concern. Okay, if we decrease the tidal volume to 700,
Yes.
what's that going to do to oxygenation?
It will
It's
improve.
not going to help it.
It's going to hurt it.
Right.
You're right. Okay, well, that's not coming out the way we thought it would. How about ventilation?
It will improve it.
It'll help.
Ventilation.
It will improve it.
Well, if your oxygenation goes down, won't your ventilation go down as well?
Not necessarily. They're two separate things.
Right.
But I'm not telling you what I think is going to happen to the ventilation. I want you guys to think about this for a minute and talk it through.
Since it's hyperventilated, so that will help.
If they're
Okay.
not breathing in as much as fast, then they're not going to be putting out as much CO2.
Thank you. Thank you. That's perfect, Connie. Okay, so let's see. Kedley and Denise were talking about it improving ventilation. It's not going to improve. Remember, ventilation is directly proportional to minute ventilation.
Okay.
If you want to improve ventilation, you need to improve or increase minute ventilation. And minute ventilation is respiratory rate times tidal volume. If your respiratory rate stays the same and you decrease your tidal volume, that means you're going to decrease your minute ventilation. which means you're going to decrease your ventilation.
I don't know how to explain it, but B would be the one that I will choose.
Okay. And you're looking ahead of us. Let me look at C. Okay, if we decrease the SIMV rate to 8 breaths per minute,
The
what is
patient
going to happen?
the patient already doing 24, so
Okay.
it not help.
So if you were in assist control and you decreased the mandatory rate from 12 breaths down to 24 breaths, it would have absolutely no effect on the patient because they would still breathe their 24 breaths per minute, and it would still give them 24 machine-driven breaths, and it would look exactly the same. When you're in SIMV, the patient can still breathe the 24 breaths per minute. The only effect that it's going to have is it's only going to have 8 machine-driven breaths per minute instead of 12. And so what often happens is the patient will actually increase their respiratory rate a little bit to help compensate, because if they're breathing 24 breaths per minute, that means 4 of those breaths are smaller breaths in comparison to what they were. So if we decrease the SIMV rate to 8 breaths per minute and the respiratory rate stays at 24, we are going to decrease oxygenation because this breath up here, these 2 breaths up here, don't go up as high as this breath here. There's a lot more surface area under that breath than there is under this breath. And everything that is above baseline is helping pull that mean airway pressure up. So now we got rid of 4 of those big breaths per minute. We're going to decrease oxygenation because the mean airway pressure goes down. How about ventilation? I want you to think in terms of what we talked about over here.
More than likely.
Yeah, well, if your rate's down, then your everything else is down too. So
Good, good. So and your rate might stay the same, but the problem is you just lost 4 big breaths and replaced them with 4 small breaths. So your minute ventilation went down, which means your ventilation goes down. And let's see, it didn't do anything to improve your tidal volume, the high tidal volume, so nothing happened with the tidal volume. Okay, so Ketley picked D, and that is the answer. So first of all, we should raise our FiO2 up to 50% or 60%, depending which book you look at, before we increase our PEEP. Okay, so that's one clue that D is correct. But in this situation, the patient is low on oxygen. You can see that up here with the 62 torr for their PaO2. And as a result, they are hyperventilating, trying to make up for that hypoxia. So if we increase the FiO2, we are going to improve their oxygenation. And because we're going to improve their oxygenation, they are not going to have to feel like they have to hyperventilate. And that will most likely fix all of those problems. Okay, they do still have the problem that the tidal volume is high, which is a concern. But the only scenario where we decrease the tidal volume is going to give us poor results for oxygenation and ventilation. So we can't pick that one.
But sometimes they give us questions like that, and they want us to choose the decreased tidal volume.
Okay, so let me put that into a scenario where you would.
Can I ask a question first before you change that?
Absolutely.
And the reason that I chose B was because in my thought process, there's more than one step to fix this problem. So the first thing would be to decrease the tidal volume and then increase the FiO2. Like, because that the tidal volume at 800 is dangerous. It could injure the patient. So to me, that would be most important, and then to increase the FiO2.
And
Okay.
I will say I have the same thought process because it's been like over and over and over. You always start with your tidal volume and then you go to FiO2 or vice versa. But on all of the things that I've read and all the things my thought process is that if you go from 35 to 50, isn't that too big of a jump?
With your FiO2?
Yeah. Or does it matter with your FiO2? Because I know a lot of them, they say small, you go up small increments, not large.
Well, but it depends because, so first of all, that's not too big of a jump because look at your PaO2. That's pretty low. I mean,
Right.
you're 18 below the minimum that you should be at. And so if you just went up 5% at a time, you would have several bumps before you would get up there.
Okay.
So no, jumping up from 35 to 50% is not too big of a jump. Now, with the tidal volume, okay, so I understand the concern because it is a concern. It's out of range. It's higher than it should be. If we really needed to know if it was dangerous for the patient, we would need to know what their peak inspiratory pressure and their plateau pressure are. Because if you can give that tidal volume of 800 and still have, say, peak pressures of 26 or 28, you're still in a safe range.
Mm-hmm.
Okay? However, I fully agree with you. Tidal volume is an issue. But one thing that you will notice with this, the NBRC is going to only have you make one change at a time. And so when you're saying, let's decrease the tidal volume and then increase the FiO2, the NBRC wouldn't ever have you do that. And especially when, in this situation, decreasing the tidal volume is going to make the other parameters worse. Okay, unless you're in a situation like, goodness, let me try this again. Like this. Let's keep that exact same scenario, but now we're going to add plateau pressures. Okay, pressure plateau at the beginning was 28. And then on the second vent check, it was 32. And the third vent check, it was 36. You see where I'm going with this, right? Fourth vent check, it was 40. It depends how high we're going to let this go up. But what we can see is this patient is going into ARDS.
Right.
Okay? And we can tell that their compliance is decreasing. It's getting worse. Because if we have, let's see.
But also on these questions too, that I've noticed on the NBRC side, a lot of these questions, they'll have the weight. They'll give you the weight and they'll also throw in the height and then they'll throw in a whole bunch of other stuff that you don't need.
They do. They're trying to fool you.
Right. So, of course, when they throw in the height and the weight, you're trying to get, that's where it would throw me off as far as saying, yeah, we need to decrease the tidal volume.
Yes, that happened to me too. Several.
Yeah. I agree. This one is a hard question. However, I think that if you went through this on your own and you saw that it was giving you poor parameters for these.
Right. I like the way you break it down. Yeah.
That you would be pulled towards D. However, if you looked at it and didn't pay attention to everything and just saw this is the only one that's decreasing the tidal volume, you would be tempted to put B. Mm-hmm. And the NBRC is betting on that. They're going to catch a lot of people because they're going to look at that, oh, we're out of range, boom. Okay, but in the real world, when we're in a hospital, we will adjust our tidal volumes outside of those ranges a lot of times because we're looking at the pressures and we're seeing what we're causing the patient. If we're in a safe zone, then we'll still be okay doing that. And so it's just kind of take a step back and look at it in regards to the entire question. If you had to do one of those, which would you do? And right now you can't make the judgment on the tidal volume without knowing what the pressures are. And so they have completely left some of that information out on purpose.
I see. So I saw this question at least 3 times, and they put it the same way.
Well, now we know it's increased the FiO2.
But make sure you don't memorize it like that. Just keep that in the back of your mind.
Yes, I saw it like decrease the tidal volume. I pick it up several times.
Yeah, I know.
Yeah.
I've done the same.
Let's see. 3 equals 35. Sorry, I'm just doing a couple quick calculations here. 35. Okay, so I just calculated the compliance between, with a tidal volume of 800 cc's, having a PEEP of 5 and a plateau pressure of 28 versus a plateau pressure of 40. So when you're at 28, you have a compliance of 35. When you're at a plateau of 40, you have a compliance of 23. So that's showing you that the compliance is going down. They are becoming an ARDS type patient. So to speak with what Connie said, that would be a situation where we would want to decrease the tidal volume, but rather than do that, what we're going to do is we are going to switch them to pressure control. And then we are going to set a safe peak inspiratory pressure. Okay, and because we set this safe peak inspiratory pressure, our tidal volumes are going to decrease. So if I went into pressure control, I'm going to say, okay, respiratory rate, let's just keep that the same for right now. So we'll say 12. And peak inspiratory pressure, let's set that at 30. That's a safe pressure to be at. However, up here, here's our normal breath that we've been doing, but this is hitting a pressure of 40. If we were to be at 30, we'd only be up at this point right here. And so when we switch to pressure control, literally our breath's going to come up to that point. And it'll hold until we get to the end of the I time, and then it'll go into exhalation. Okay, so you can see that at the pressure of 30, the tidal volume is going to be much less than it is at 40. And that's how we would handle this patient. We would put him into pressure control so we can assure that the pressure is not going to go above what we set it at. And we are going to allow the patient's CO2 to rise. We know that that's going to cause the pH to decrease. We're going to oxygenate them as good as we can using a high FiO2 and a higher PEEP. And we are just going to keep this patient sick for a long time and help them get through it rather than let the patient die.
Right, because it's better to have a sick one than a dead one?
Yep, absolutely. Does that make sense to you guys?
Yes.
Okay. So absolutely, if we're getting high pressures, then that respiratory or that tidal volume is going to have an increased significance to us. It still is important. Our warning bells are going off like crazy, but we were only given this 4 choices to choose from, and in this situation, D is the best. Or maybe we should say it's the least bad, because it is going to fix some of this oxygenation problem. It just isn't going to fix that high tidal volume. Okay, that is the end of what I have prepared for you. Do you guys have questions for me?
I'm okay.
Yeah, I think this has helped a lot.
Good, good.
Thank you.
Okay, my pleasure. So this is the last of the mechanical ventilation lectures, which means that I just need to upload this lecture and I need to upload the previous lecture into YouTube, which takes a little while, and then I will be able to send you guys a Microsoft Word document that has a link for all the lectures that we've done. So if you are weak in one of the areas, you can literally just go pick which lecture you want to listen to and listen to that. It also has the new one by Daryl Goliford, his new and improved 2017 TMC lecture, which is fantastic.
I love it.
And I will also put the link on it for these lectures. In case you guys ever lose the link, it'll be a place where you can quickly get it. So, but it may be a few days before you get this. This is just stuff that I'm doing in addition to my normal teaching. And so I just have to get some time freed up to where I can upload them and get them to you guys.
Yeah, could you do that? Because I plan on testing next week.
Good. Yes, I will happily do that. And if you don't see it, say, what are we, Tuesday? If you don't see it by Thursday, email me
Okay.
and remind me and make sure that I give it to you. And that way also, if I've sent it out by then and you didn't receive it, then I need to make sure that I email it to you directly through your personal email.
Oh,
Okay. So next week, we're still going to do them. We're going to start over, I think, next week is blood gas, I believe. And so we'll just keep going through these lectures, and you're welcome to attend as much as you would like.
Awesome.
Okay. Thank you, guys. I hope you have a
thank
wonderful
you,
day.
Kevin.
You
Thank
bet.
you.
I will send this specific link to you guys within a day or so. So it'll just automatically come to you.
I missed the third one. But since you said you're gonna send all of them, thank
You know
you.
what? I'm trying to think. I thought I sent the third one out.
No,
Did I not?
no.
Oh my goodness. I am so sorry. I will send the third and the fourth one out. Did you say you got it, Connie?
Well, my dad are listening to it.
Okay. All right, so I probably forgot to do that because I had it saved there to upload to YouTube, and I was just not thinking straight. Okay, I'll send them both to you guys.
Okay, thank you very
Okay.
much.
You bet.
Thank
Have a
you.
great day.
Okay, thank you.
Yeah, bye.